Hello, this is the second part of my presentation about glycolysis. And if you've missed the first part, here's a link right here. And the start of this presentation will be a summary of the first part of my presentation. I'm going to be using a mnemonic, which is this one. Goodness gracious, Father Franklin did go by picking pumpkins, preparing pies. This is actually a mnemonic for each step of the glycolysis. Let's try and look at it together with the mnemonic. Let's run through it. So G, goodness gracious, glucose 6-phosphate. So it's goodness gracious. Father Franklin is fructose 6-phosphate and fructose 1,6-bisphosphate. Father Franklin did go by, so it's D, dihydroacetone phosphate, go G, glyceraldehyde acetone phosphate, B, 1,3-BPG, 1,3-bisphosphoglycerate. Picking pineapples? No. Picking pumpkins, phosphoglycerate and 2-phosphoglycerate. Preparing pies, the PEP, that's phosphanol pyruvate and pyruvate kinase. Preparing pies, pyruvate. Okay. So I hope that makes sense. Goodness gracious, Father Franklin did go by picking pumpkins, preparing pies. Okay. So this part, the second part of my presentation about glycolysis, I'm going to be talking quite a lot about enzymes. So the first enzyme I'm going to be looking at is the hexokinase and the glucokinase. In the first part of my glycolysis presentation, I've already mentioned that by having the change of glucose into glucose 6-phosphate, it sort of keeps this glucose that the cell have invited into the cell interior and sort of prevents it, sort of like it keeps the glucose in the cell, but because the glucose 6-phosphate doesn't have a specific cell membrane transporter to go through outside. So glucose can go outside, however the glucose 6-phosphate can't. So that it's a good way to keep the glucose inside the cell, sort of like inviting someone and sort of giving him a cup of tea so that the person can't leave just yet. Okay? I'm going to be talking about glucokinase. Glucokinase is a very important enzyme because basically it does the same thing as hexokinase. However, it has many added properties which makes it better for it to control the rate of glycolysis. So when the sugar level is high inside the blood or outside the cell membrane, the glucokinase starts to act. And when the glucose 6-phosphate concentration is high, it also actually inhibits the hexokinase activities. So it does make sense, right? That if you have too many glucose in the system, you would want to use it up by glycolysis. But if there's too much G6P, which means that the reaction isn't going as fast as you want, then you want to sort of slow down so that the G6P has more time to go on to the next reactions. Okay. Glucokinase properties. It has much lower affinity to glucose, only working when glucose level is high. So glucokinase is kind of lazy, but it works when it has to work. So you always have that person who does a presentation very last minute, which is me. But this person who does the presentation last minute also always does it when everyone's like, there's too much things to do, I can't do it. Then only the person will do it. So in a sense, it serves a function. It is present in the liver, pancreas, hypothalamus, small intestine, and perhaps certain other neuroendocrine cells, and plays an important regulatory role in carbohydrate metabolism. In the beta cells of the pancreatic islets, it serves as a glucose sensor to control insulin release, and similarly, controls glucagon release in the alpha cells. So it's sort of like a sensor as well. Very smart little enzyme, this glucokinase. In hepatocytes of the liver, glucokinase responds to the changes of ambient glucose levels by increasing and reducing glycogen synthesis. So it serves a very special role in the liver because it's sort of like it's responsive to the glucose levels. Okay, moving on to I'm going to talk about glucose 6-phosphate because it's an important step. Why? Because it serves as a crossroad to other reactions other than the glycolysis pathway. It has a connection with the pentose phosphate pathway. What is the pentose phosphate pathway? It's basically a pathway that serves to create NADPH and nucleotides. It also serves as a pathway towards glycogen and back from glycogen back to glucose 6-phosphate. So glycogenesis and glycogenolysis, both ways. It enters the glycogen enters the. We can say that the glycogen enters the glycolysis pathway by the glucose 6-phosphate. Okay. Yep. Now I'm going to be talking about PFK or phosphofructokinase, which is the enzyme that controls the rate of glycolysis, and it's also a point of commitment. It's sort of like from this point onwards, there's no turning back. Just like when a couple, after several maybe months or years of relationship, they decide to get a house together in their joint account. So there's really no turning back, really. Kind of scary if you think about it. Anyway, phosphofructokinase is very important because not only it is a irreversible step of the reaction, it is also really tightly controlled. Let's talk about that control. What kind of control does it have? Firstly, it is inhibited by high levels of ATP, which makes sense because glycolysis serves to make ATP. So you need more energy. But if you already have a lot of energy, there's no point in breaking down more glucose than it's needed. So if you have more ATP, then PFK doesn't work. Okay? If there is more AMP compared to ATP, then the inhibitory effect of ATP will not work anymore. Which means that AMP basically is an energy depleted ATP. So AMP is a step further compared to ATP, ADP, and then AMP, which means it's a really, really depleted form of ATP. So you can say that it's a form you can only see sort of when the cell is really deprived of energy. So when there's AMP, then you will really have to try hard to make more ATP. So this makes sense because you don't want the phosphofructokinase action to be diminished. Next, low pH actually inhibits the action of phosphofructokinase, which kind of sounds like it's counterintuitive. Does it make sense? Because low pH means there's lactic acidosis, which means that the cell has been working under anaerobic conditions. So doesn't it supposed to sort of like aren't we supposed to create more energy so that you can overcome the amount of anaerobic and the exercise you're having? Actually, this is so that we can prevent damage of muscles, because if you don't have oxygen, you're going to create more lactic acid. And if you keep on going and if you keep on producing energy for that kind of exercise, you're going to hurt your muscles, because if there's too much acid in your muscles, eventually it's going to irreversibly affect the structure of the muscle cells. So it makes sense that the lactic acid will inhibit phosphofructokinase. Moving on, there's an enzyme called PFK2, which is a different kind of enzyme compared to phosphofructokinase 1. and this is controlled by glucagon. And PFK2 will create what is called the F26BP, which is actually a very important control factor of phosphofructokinase, and it actually promotes it. Let me try and explain this. This is what is called a feed-forward stimulation, where if you have a lot of F6P, then PFK2 will start to work and say, hey, I think we have to increase the rate of conversion. And hence, there will be more of this being created, and hence phosphofructokinase will start to work hard. Okay? I've added in things that would inhibit action of PFK, like PEP, which is the downstream product of glycolysis. Citrate basically is the same thing, the downstream product. And what else? Insulin will promote the action of F26BP. Makes sense, because insulin basically wants to reduce the sugar level, right? So to reduce the sugar level, break down more sugar. Now, okay, I'm sure this is pretty complicated, so I just summarized it here. So promoters of PFK is AMP, presence of AMP, high levels of F6P, presence of insulin, and presence of serotonin. Inhibitors, on the other hand, is high levels of ATP, high levels of PEP, citrate, low pH, and presence of glucagon. Okay, I think the bulk of what I wanted to do in this presentation is over, but let me just put in a bit more things inside. Okay, I'm going to be talking about analase. What is so special about this step? Analase is actually inhibited by fluoride, and fluorides are very special for dentists, especially. What does it do? Basically, it will prevent oral caries, right? And I can sort of explain this in a sense that oral bacteria, they will have to carry out glycolysis in order for them to live. However, if you have fluoride in your mouth, these oral bacteria can't carry on with the glycolysis because this analase is being inhibited. So therefore, when you're giving fluoride to a patient to prevent oral caries, you're preventing this step. Interesting to note. Lastly, what I want to say about is pyruvate. Pyruvate is extremely important because it is the pathway for the glycolytic pathway to enter the Krebs cycle, but it is also the pathway to the alanine pathway through the alanine transaminase. It's also the pathway to lactic acid through lactic dehydrogenase. It's also a pathway to fatty acid synthesis through acetyl-CoA. By the way, acetyl-CoA is also a crossroad for a lot of reactions, but I will not bore you with the details as of now. And thank you very much for your attention. I think I'm done with glycolysis until further notice. Thank you so much, and see you next time.